Welcome to Astronomy Daily, your daily briefing from the edge of the cosmos. I'm Anna.
And I'm Avery. It is Tuesday, the 26th of May, 2026, and we have an enormous show for you today.
NASA is literally, as we record this, preparing to unveil the most ambitious lunar plan in a generation. We're talking about a permanent moon base.
Starship V3 made its dramatic debut. A Soviet rover that vanished nearly 40 years ago has quietly come back to life. And the James Webb Space Telescope has pulled off something no telescope has ever done before.
Plus, a supernova mystery that took 20 years to crack, and a finding about rocky planets across the galaxy that could reshape how we think about worlds like our own.
Let's get into it.
Our lead story today is one for the history books, and uniquely, it is unfolding right now as we speak. As we record this episode, NASA Administrator Jared Isaacman is preparing to take the podium at NASA headquarters in Washington, D.C. for a 2 p.m. Eastern press conference that could define the next decade of human space exploration.
The headline is this: NASA is announcing a permanent moon base, a real one, not a visiting program, not flags and footprints, a sustained human outpost at the lunar South Pole with a target date of 2036.
What we know going in is significant. The program carries a price tag in the region of $30 billion across a 7-year foundational phase. It centers on the lunar South Pole, chosen because that region contains water ice in permanently shadowed craters, which NASA plans to convert into rocket fuel, oxygen, and life support systems.
Critically, this plan effectively retires the Gateway concept, the proposed orbiting lunar space station that's been on the drawing board for years. The thinking is that the resources and launch cadence needed for Gateway are better directed toward getting people on the surface and keeping them there.
Nuclear power is central to the architecture. Both the base itself and potential future Mars missions are expected to rely on nuclear electric systems, a choice the Planetary Society has flagged as potentially transformative for deep space operations. As Casey Dreyer put it, nuclear propulsion could open up huge opportunities for energy use in various science missions and crewed missions around the solar system.
Phase 1 alone calls for approximately 22 launches to the moon, including the Artemis 4 crewed landing by 2028. Those early flights will serve as the proving ground. If they go smoothly, the program earns its next phase. If there are hiccups, the timeline shifts.
Commercial partners will play a major role, supplying rovers, habitat modules, and surface logistics. International collaboration is also baked in, though the competitive context is hard to ignore. China has announced its own international lunar research program targeting the 2030s, and multiple nations now have advanced lunar capabilities.
NASA's framing going into today's briefing has been unambiguous. As Isaacman put it in the lead-up, this time the goal is not flags and footprints. This time the goal is to stay.
By the time our listeners hear this episode, those full details will be public. We'll have complete coverage in tomorrow's edition. But what a moment to be covering space news. The moon isn't a destination anymore. It's becoming an address.
Staying with big space news, and this one delivered drama in spades. On Friday, the 22nd of May 2026, SpaceX launched Starship V3 for the very first time. Flight 12. The most powerful and most sophisticated rocket ever built, now in its third-generation configuration.
And it did not disappoint, though perhaps not entirely in the way SpaceX had planned. Let's walk through what happened, because this is a story with multiple chapters. The launch came from brand new Pad 2 at Starbase, Texas, itself a first. After 2 scrubbed attempts, one foiled by a hydraulic pin issue literally in the final minutes of the countdown, Starship lifted off at 6:33 p.m. Eastern on Friday. All 33 Raptor engines on the Super Heavy booster lit cleanly.
The ascent looked textbook, right up until approximately 1 minute and 42 seconds into the flight, when one of the 6 vacuum Raptor engines on the ship upper stage shut down. Now, in most rocket programs, that's a mission-ending event.
Not here. Starship's flight computer detected the shutdown, instantly redistributed the burn load across the remaining 5 engines, extending their burn durations to compensate. The vehicle stayed on trajectory. SpaceX spokesperson Dan Hewitt on the live commentary put it this way: the flight was within analyzed bounds, even if it wasn't fully nominal.
Ship 39 reached space, deployed 22 dummy Starlink satellites, including 2 specially equipped with cameras that captured stunning imagery of Starship in orbit, and then executed a controlled atmospheric re-entry, splashing down in the Indian Ocean as planned. Elon Musk called it epic and a goal for humanity.
NASA Administrator Isekman, who was watching in person at Starbase, wrote on X, "One step closer to the moon, one step closer to Mars." Given that Starship is the intended vehicle for the Artemis crewed lunar landing, that's not a casual observation.
Now, the Super Heavy booster did not have such a clean ending. Multiple engines failed during the boostback burn, the stage went off normal, and it came down hard in the Gulf of Mexico rather than completing a soft splashdown. The FAA has opened the review, as is standard after any anomaly over navigable waters.
SpaceX had planned a splashdown rather than a tower catch on this first V3 flight, so losing the booster was within acceptable test parameters. The company has formally declared most of its pre-planned test objectives as completed.
The V3 design brings significant upgrades over previous iterations: larger propellant capacity, simplified aft sections, new Raptor 3 engines with higher thrust and reduced complexity, and ground infrastructure at Pad 2 designed for a much higher launch cadence. This flight was about proving those systems in the real environment.
It proved quite a lot. Flight 13 will be very interesting indeed.
Now, to a piece of science that genuinely made us sit back and marvel. The James Webb Telescope has done something no telescope has ever managed before. It has watched a daily weather cycle unfold on a planet in another star system.
The planet in question is WASP 94AB, a hot Jupiter about 690 light-years from Earth in the constellation Microscopium. It's a gas giant, 1.7 times larger than Jupiter, orbiting its star every 4 days at a distance of roughly 8 million kilometers. Temperatures on its day side exceed 1,200 degrees Celsius, and it is tidally locked, meaning one face always points toward its star, the other always faces away.
The research team, led by Sagnik Mukherjee, a postdoctoral researcher at Arizona State University who began this work as a PhD student at UC Santa Cruz, used Webb's NIRRI instrument and a technique called transit spectroscopy to observe the planet as it crossed in front of its host star.
And what they found was extraordinary. The leading edge of the planet, the side rotating from night into day, the planetary morning, was blanketed with thick clouds made of magnesium silicate. Sand clouds, essentially. The same mineral found in talc and ordinary rocks on Earth, vaporized and condensed high in an alien atmosphere.
But by the time the trailing edge, the evening side, came into view, those clouds had completely disappeared. A cloudy dawn, a clear dusk, a weather cycle repeating every 4 days with the planet's orbit.
Co-author David Singh of Johns Hopkins University captured the significance beautifully. He said, "I've been looking at exoplanets for 20 years, and general cloudiness has been a thorn in our side. We've known for quite a while that clouds are pervasive on hot Jupiter planets, which is annoying because it's like trying to look at the planet through a foggy window."
Webb's ability to separate the morning and evening limbs of the planet, something the Hubble Space Telescope simply cannot do, gave researchers their clearest view yet of the atmosphere itself. And what they found there was a surprise. WASP 94AB is far more Jupiter-like in composition than a decade of Hubble data had suggested.
Previous measurements had indicated the planet had hundreds of times more oxygen and carbon than Jupiter. The new cloud-corrected analysis brings that down to roughly 5 times, a full order of magnitude correction, and a reminder that unresolved clouds can seriously skew our picture of what other worlds are made of.
The team didn't stop at WASP 94AB. They found the same cloud cycle pattern on 2 other hot Jupiters, WASP 39b and WASP 17b, suggesting this isn't an anomaly, but a recurring feature of how hot Jupiter atmospheres behave.
Researchers now plan to extend the survey to planets on highly eccentric orbits, worlds that experience dramatic temperature swings, where even more extreme weather patterns may be waiting to be discovered.
Weather forecasts for alien worlds. We are living in remarkable times.
For nearly 20 years, astronomers have been puzzled by a class of stellar explosions so bright they break the rules. Superluminous supernovae, stellar deaths that produce 10 times or more the visible light of an ordinary supernova, up to 100 times brighter in some cases. The question has always been, what is powering them?
Now, data from NASA's Fermi Gamma Ray Telescope has delivered the first definitive answer, and it involves one of the most extreme objects in the known universe.
The story centers on SN 2017 EGM, first spotted by ESA's Gaia mission back in May 2017. An international team led by Fabio Acero at the French National Center for Scientific Research has now confirmed that Fermi detected gamma rays, the most energetic form of light, coming from this event.
That confirmation matters enormously because gamma rays carry the fingerprint of what's actually happening at the core of the explosion. And what Fermi's data reveals is a magnetar, a neutron star born in the same stellar collapse that triggered the supernova.
To understand why that's significant, consider what a magnetar is. When a star many times the mass of our sun exhausts its fuel and collapses, its core can compress into a neutron star, roughly the size of a city. Magnetars are the most extreme version of those objects, spinning hundreds of times per second, generating magnetic fields 1,000 times stronger than those of ordinary neutron stars, the most powerful magnetic objects in the known universe.
The model works like this. The newborn magnetar's furious rotation generates an outflow of electrons and positrons, matter and antimatter particles, that forms a vast cloud of energetic particles. That cloud pumps energy back into the expanding shell of stellar material, supercharging the explosion and making it shine far brighter than any ordinary supernova.
The team compared optical and gamma ray data from SN 2017 EGM against theoretical models of exactly this process, and the match was compelling. As Fabio Acero put it, for nearly 20 years, astronomers have searched Fermi data for gamma ray signals from thousands of supernovae. And while a few intriguing hints have been reported, none were definitive until now.
This is a genuine first, a direct observational window into the engine driving the most powerful stellar explosions in the cosmos.
And it opens a new avenue for future research. The team has assessed how the upcoming Cherenkov Telescope Array Observatory, a next-generation ground-based gamma-ray facility, will perform at detecting similar events. The era of magnetar forensics is just beginning.
A mystery that's been open since the early 2000s finally cracked, and the answer is a star corpse the size of a city spinning like a cosmic dynamo.
Here's a finding that quietly challenges one of our most fundamental assumptions about what planets are made of, and it matters a great deal for how we think about habitability beyond our solar system.
A new paper submitted to the Astrophysical Journal proposes that the structure we take for granted here on Earth, a dense metallic core surrounded by a silicate mantle topped by a thin crust, may be the exception rather than the rule for rocky planets across the galaxy.
For decades, planetary scientists have used our solar system as the template. Earth has a metallic core, Mars has one, Mercury, though radically oversized relative to the rest of the planet, has one. The assumption, largely unchallenged, was that rocky planets formed this way. Heavy metals sank to the center during the molten phase early in planetary history, creating the familiar layered structure.
But when you look at the full range of rocky planets now cataloged, and we have confirmed over 6,000 exoplanets as of this year, with many hundreds in the rocky category, the diversity of compositions is striking. Rocky planets form in vastly different stellar environments, with different ratios of iron, silicate, and other materials depending on the chemistry of their parent nebula.
The researchers argue that many of the most common rocky planets in the galaxy, so-called super-Earths and sub-Neptunes, may have formed in conditions where metallic core formation simply didn't occur in the same way, or at all. Without that dense metallic core, you don't get a global magnetic field generated by a dynamo effect.
And that has profound implications for habitability. Earth's magnetic field shields our surface from the solar wind. Without it, our atmosphere would gradually be stripped away over geological timescales. Mars lost most of its magnetic field billions of years ago, and look at it now.
If the majority of rocky planets across the galaxy lack that protective magnetic shielding, the calculus for finding life-friendly worlds changes considerably.
It's a sobering and fascinating paper, and a reminder that our solar system, for all its familiarity, may be showing us a rather unusual version of what planets typically look like.
We're closing tonight with a story that has everything. Cold War history, a decades-long mystery, a surprising rediscovery, and a laser beam fired from New Mexico to a hillside on the moon.
Cast your minds back to November 1970. The Soviet Union lands Luna 17 on the moon's Sea of Rains, Mare Imbrium. Out rolls Lunokhod 1, a bathtub-shaped, 8-wheeled rover bristling with scientific instruments, the world's first remote-controlled vehicle to operate on another world.
It was designed for a relatively short mission. Instead, it kept going, surviving 11 lunar day-night cycles, traversing roughly 10.5 kilometers of the lunar surface, sending back thousands of photographs and mountains of scientific data. Then, in the autumn of 1971, contact ceased. Mission over.
But here's the thing. Mounted on Lunokhod 1 was a French-built laser retroreflector, a passive optical device that requires no power whatsoever. Its only job is to bounce laser light back toward wherever it came from. And that device was still there, perfectly intact, waiting.
The problem was that no one knew precisely where Lunokhod 1 had ended its journey. The rover had moved across the surface during its mission, and without high-resolution orbital imagery, pinpointing its final resting place to the precision needed for laser ranging was impossible. For nearly 38 years, it sat there, silent, invisible, scientifically, tantalizingly out of reach.
Then, in 2010, everything changed. NASA's Lunar Reconnaissance Orbiter sent back high-resolution imagery of Mare Imbrium, and researchers spotted it. The rover and its landing platform, still sitting exactly where they'd been left.
With updated coordinates in hand, a team from the Apache Point Observatory Lunar Laser Ranging Operation in New Mexico, the Apollo project, fired laser pulses at the site in April 2010, and Lunokhod 1 fired back.
Not metaphorically. The retroreflector returned approximately 2,000 photons per shot, roughly 4 times stronger than the returns from Lunokhod 2, and stronger than expected from a reflector that had spent nearly 4 decades exposed to the lunar environment.
The location turns out to be scientifically valuable in ways researchers hadn't anticipated. Lunokhod 1 sits closer to the lunar limb than any of the Apollo reflectors, a position that improves measurements of the lunar librations, the subtle wobbles in its rotation, which in turn help refine models of the lunar interior.
And there's a puzzle that the recovered reflector is helping solve. Near full moon, the strength of laser returns from all reflectors drops by a factor of 10. No one fully understands why. Lunokhod 1's strong returns from a different geometry are providing new clues.
Long-term laser ranging, now including this recovered Cold War relic, has given us some of our most precise measurements of how the moon is slowly drifting away from Earth at about 3.8 centimeters per year, and has contributed evidence for the existence of a fluid lunar core.
A rover that fell silent in 1971, rediscovered from orbit, resurrected by a laser pulse, and still contributing to science today. Sometimes the best stories don't end. They just go quiet for a while.
And that wraps up Astronomy Daily for Tuesday, the 26th of May, 2026. From a moon base that could redefine human civilization to a Soviet rover whispering back from the lunar surface. What a day to be paying attention to the cosmos.
If today's episode sparked something for you, please subscribe, leave a review, and share us with someone who needs more space in their life. You'll find full show notes, links to all our sources, and our blog post at astronomydaily.io.
Find us on social media. We're at Astro Daily Pod across X, Instagram, TikTok, and Tumblr.
For Anna, I'm Avery. Keep looking up.
Astronomy Daily, every day from every corner of the universe.